get to chapter 15. End of the class, right here. Here we go. I guess I'll let it here. Go ahead. I already posted the list of topics, but I forgot to open it. But what it says up there is moving averages, weighted moving averages, exponential smoothing, trend projection, and MAE, and MSE. And what did I say? Trend projection, right? Trend projection. Those are the items that are not, that you don't see up on the screen right now. Trend projection is a forecasting technique. Moving averages, weighted moving averages, and exponential smoothing. So 4 forecasting techniques and 2 error calculations, ERROR calculations. The mean absolute error and the mean squared error. But this one, we're going to say, boy, I don't have time to study both of these. I would suggest this one, only because in real life, this has been the one that I ended up using the most because it was the best one that helped me figure out which forecasting technique I should be using. You ready? The first 2, moving averages and weighted moving averages, I'm going fast on purpose because they're so easy that if you don't get it because I'm going too fast, watch the video because they're really easy. Something will click. If it's not clicking during this lecture, it'll click in the video because they're just that easy. The rules I write down, the little things you got to remember about them. Let's start with moving averages. Ready? Whatever amount of periods of moving average, there could be like 2 period, 3 period, 4 period, 5 period, 6 period. It will tell you the number of periods, and it'll say moving average. Whatever amount of periods you use are the periods before the period you're forecasting. So, for example, let's start with a 3-period moving average. And I said, I want you to forecast period 6. You're going to look at the periods 3 before 6, 5, 4, 3. And you add up their numbers, and then you divide by 3, and there's your forecast for period, what did I say, 5? 6? For period 6. So, let's look at one. I know it's going fast, it's just that easy though. There's some data. You ready? I want to do a 3-period moving average. Now this is actual data, and you would think we're going to forecast the future, but all this lecture is all about forecasting for periods we have actual data for, so we can compare the technique. That's what happens in forecasting. I had to do tons of forecasting to do budgets. And it was always, to start my forecast, I would get all the previous information I could, and then I would take every technique that I thought would maybe fit that data, and I'd test them all. I have it all set up on Excel, where all I got to do is just change this and change that, and it all happens really fast. That's the whole point. You've got to test these different techniques. You're going to calculate how much error that technique is using, and you're going to either get the MSE or MAE, which, now here it is, whichever technique has the lowest MSE or MAE is the one fitting the data the best. Now you use it to forecast the future. You got a lot of work though before you ever forecast the future. It's finding the technique that fits the data the best. By doing that, your forecasts of the future have much higher probability of being darn close to what really will happen. As long as everything's semi going normal. Unless there's some kind of economic collapse, recession jump in because of a financial thing, it blows your whole forecast out of the water. You got to redo everything. Okay, everybody get that? So here's the deal. 3-period moving average. Let's say I'm going to ask you for forecast period 7. What 3 numbers would I use that I would then divide by 3? You ready? 3-period moving average. Give me one of the numbers. Wait, what do we forecast? I'm sorry. Go ahead. Well, yeah, those are the weeks, but what are the numbers?
23.
23, I hear. 18 and 16 divided by 3. There's your forecast for period 7. I looked at the 3 periods before whatever period I'm forecasting. I used those. I said, oh, it's 3 period. I'll use 3 periods data. I'll divide by 3. You're finding the average. Let's do a 2-period moving average. Forecast period 9 for me. We're going to divide by 2. Go ahead. Give me the numbers.
16.
No, wait. Forecast period 9. 2-period moving average. Forecast period 9. Thank you. 20 and 18 divided by 2.
19.
Adam divided by 2. 2-period moving average. You're using the 2 periods that are before what you're forecasting. Now, if I were asking you to do every possible forecast to compare to actual data you can do, where would be your first forecast? Now, you can't do one for period 1, but where would be? 2-period moving average, your first forecast would be where? 3. You can't have a forecast for 1. You can't have a forecast for 2. You can have it for 3, 4, 5, all the way to 12. The reason this is important is because when you're calculating those errors, the last step is dividing. You only divide by however many forecasts you were able to compare to actuals. And since you can't do the first 2 periods, when you get to the last step of these error calculations, you divide by the number of forecasts you could do to compare to actual, not all 12 periods or however many periods there are. You ready? 4-period moving average, my first forecast is where? 5. Then 6, then 7, then 8. I'm calculating the error. How many forecasts do I have that I could divide when I get to the end of that calculation you're about to learn? How many forecasts have I? My first forecast is in period 5. 8. 12 minus 5, because you can't, right? Wait. 12 minus 4, because you can't have a forecast with 1, 2, 3, or 4. You have to have 4 periods of data to get a forecast. So your first forecast is 5 through 12. You're going to divide by 8 when we get to that calculation, the error one coming. Do you feel confident that you can tell me how to calculate the moving average of any forecast I'm about to tell you to do? For example, I want a 3-period moving average for period 13. This is a 3-period. I'm dividing by 3. Give me the numbers. 20. 15 plus 22. The 3 periods before wherever you're forecasting, because it's a 3-period, you add them, divide by 3. That's moving average. You're done with moving average. It's that easy. All right. Next, weighted moving average. The concept is the exact same as far as where you can do your first forecast or what periods you use to do your forecast, but the math is different. All right. So let me see here. Well, that's some good handwriting. Let's do 3-period. Now, before I even write weighted moving average, I'll put weighted. And I want to do a forecast for period 10 without knowing the math, without knowing how to do weighted moving average. You can tell me what periods to use, or not just what periods, but what numbers would be used. If I'm forecasting period 10, give me the numbers that would be used. 20, 18, 22. Exactly. Same concept as moving average, right? That easy. But instead of dividing by however many numbers you're using, you multiply each number by the weights that are in the directions, that are in the problem being told to you. And they're going to say something like this. Let's see, this is period 10, it's a 3-period. It will say something like, use 40% for your most recent piece of data. Use 35% for your oldest piece of data, and then what's left? It's always got to add up to 100%. What am I at, 25? And use 25% for the other, or maybe it will say middle, something like that. But if you know one's the most recent piece of data, the other one's for the oldest piece of data, and it's the 3-period, the other one must be the middle piece of data. Here's the deal. To determine which one's the most recent and which one's the oldest, all data is in order from oldest to newest. Number 1 is your absolute oldest piece of data in any of these. The whole stats book, the whole management science book, the oldest piece of data is always at the number 1 period. If there's 12 periods, your most recent data is the 12th period. If there's 10 periods, your most recent data is the 10th period. Your most recent's always at the bottom. Lauren, you got that? Just check. All right, at the table. All right.
What page in the book is this?
This is not in the, this is in the book, but I don't know what page. I took a picture of it so I wouldn't have to.
Chapter 15.
Yeah, I got that. Page 656 at the bottom. Thanks for the chapter. I wasn't sure what chapter it was. All right. 3-period weighted moving average. Here we go. It says right there, use 40% of the most recent data. 0.40 times, what is the most recent data? We're forecasting period 10. Give me the most recent. 22. Plus, says 35%. 0.35 times the oldest piece of data, 3 periods, period 10. Give it to me, Jasmine. 20? Is that right? Yes, it is. Thank you. Now, I'm going to add to that 0.25, 25% times the other piece of data, which would be what? That's very good. No dividing. The percent times the data that it says to use, the other percent times the data, the other percent times the data. You read it and figure out which piece of the data go with which percent.
Will you always give us a percentage?
Always.
Or?
Always.
Okay.
It'll always add up to 100%.
So isn't going to always be the 40, 35?
No. It'll be different ones. And plus, it could be a 4 period, so you have 4 percentages. It could be a 2 period, you only have 2 percentages.
Okay.
So you got to kind of figure it out. Let's do a 4 period, because that one's a little harder, because I got to describe the data in the problem that I can't just go with most recent, oldest, and middle. I'm going to have to go with like second oldest, or be a third one described. And then other will be whichever one after the other 3. So let's do one more. Let's do the weighting again. Hang on, I'm going to try to save time here. Boom, boom, boom. I'm going to add, let's see, let's make this one second oldest. Come on. Second oldest. Now I'm going to put, whenever I use weighted averages, I usually always put more weight on the most recent data, because the most recent data is describing what's happening kind of right now, where the oldest piece of data is kind of describing what was happening in the past. So I like more weight on what's happening now. So I'm going to put 50% here. The oldest piece of data, I'm putting 10%. The second oldest piece of data, I'm putting 20%, 50, 60, 70, 80. Other, middle, or whatever I'll call it other, is going to equal, you guys can't see it over there, I go over here. I just forgot, 20%? Is that right? 50, 60, 70, 80, 20. I got 2 20s, a 10, and a 50. Ready? Natalie, you ready? Help me. You help me?
Sure.
Okay, 4 period. I want to do a forecast for period 7. 7, are you ready? I'm going to give you a percentage. Now, I'm going to read it to you again, because I can tell it's 50% for the most recent, 10% for the oldest piece of data, 20% for the second oldest piece of data, so you're looking at it now, 20% for that other one. Give me the 50%. 50%, we're doing a forecast for period 7. The 50% times the most recent data, what number? Josh, are you whispering that to her? No. I can hear you. Just like now you're pretending you're talking without your lips moving, like you got a puppet.
16.
Okay, 50% times the 16 plus, do the 10%. 10%. That doesn't look like a plus. 10%. Stop, Josh.
That was her.
Okay.
That was me.
I gotta look. I don't even know the answer right here. Okay, what number?
19.
Is it 19? Is that going back 4?
Yeah.
Hang on, I gotta look again. I was going one more. 1, 2, 3, 4. Yeah, 19. 10% times 19 is 10. Hang on. I'm gonna write 0.10 times 19 plus. Let's do the 20%. 0.20 times. Hang on, I gotta look. Natalie, you agree?
What'd they say?
I don't know what number you said.
23.
I said 20. Oh, no, I did say 23. I said 18, but if anybody around me heard me, I swear.
That's my sister backing up my other sister when I know she's lying. No, my sisters. Well, I'm not talking about you guys. It's all about my sisters. That's too much. So, all right. Here we go. 20% times the other piece of data, which would that be?
Yeah, that's
We did the second oldest piece of data, we did the most recent, we did the oldest, there's one more piece of data. We
The
gotta look at it.
23 was the other.
18, that's it. Here's the oldest, right here, 23, second oldest 18, the other was the 16 right here, right? We got 16? Oh wait, no, I'm sorry. Right here. 1, 2, 3, 4. Here's the oldest, here's the second oldest, here's the one that's the other, and then here's the most recent. And we got 18 in the other, so we're fine. Anyway, remind me not to do a 4 period on the final, that's too many. I can tell.
Reminded, don't get 4 periods. Just don't do it.
Okay.
I think I know what you need some lines.
Don't
You need to
cross.
do like
I think
Quarter
we
1,
did them
quarter
out
2,
of
quarter
order.
3, quarter 4. That's
Yeah, we did them out of order.
Yeah.
Quarter 2,
You do the most recent, oldest, second oldest.
Tyler, are you ready?
Yeah.
Let's do it. Here we go. Let's do it. You ready? 2 period moving average, Tyler, 60%, 40%. I want a forecast for a period. This is too easy. This is too easy. He's smiling so big because it's just too easy. Hang on. Hang on. Hang on. We're going back. We're going back. 60, I got another 20 with other. Okay. Hang on. We're doing a forecast for period 13. Tyler, go ahead. Start with the 60% times.
22,
Very good. Let's go with 20%, either one. 15. Let's go then plus 20% times 20. And there's the answer for forecast period 13. Each of the percentages times, you add them together. That's the only difference, the adding and times compared to the moving average without weights. Too easy, right? We're okay? Everybody?
You can stop there.
Stop there?
Yeah.
Oh, okay. Was Ashley? Oh, Josh, that was you? You guys ready? We ready? Okay, it's going to start to get a little harder. I want to make sure everybody's with me before I continue. Bianca, we're good? Alexis, we're good? Just making sure. You ready? Exponential smoothing. How do I describe this? The first thing I need you to put in your notes for exponential smoothing is there's no calculating for the first forecast. No calculating for the first forecast. The first forecast is always the first period actual. Everybody hear that? The oldest period is the first period. Whatever the actual is, it's also the forecast. So my question for you is, if we were doing exponential smoothing, which you haven't even learned the calculation yet, you could tell me the first forecast. What would it be? 17. Because that's the first actual. You just boom, boom. Okay? Now, you're going to be giving what's called a smoothing constant. The smoothing constant is always between 0 and 1. 0.2, 0.3, 0.25, 0.55, something like that. The opposite of the smoothing constant is like 1 minus the smoothing constant. For example, if I said 0.3 is the smoothing constant, the opposite would be 0.7. Thank you, Josh. All right. If I said the smoothing constant is 0.6, the opposite would be, other than Josh? 0.4. Thank you. You got it. Now, the formula is the smoothing constant, which is this symbol, I'll call it SC. Smoothing constant times the previous period actual. Come on. Whoa. Smoothing constant times previous period actual plus 1 minus the smoothing constant, the opposite of smoothing constant, times, put this on here, previous period forecast. Everybody hear that? So let me start with period 1. The actual is 17. The forecast is 17. Period 2, we're going to use a smoothing constant of equals, give me one, Josh.
0.7.
0.7. There it is. So I'm going to go 0.7 times the previous period actual which is 17, plus the opposite of 0.7, which is 0.3, times the previous forecast, 17. You do the math on this, and this always happens on period 2. It happens to be the same forecast as period 1, because the actual and forecast are the same, because the first step is to use the actual for the forecast.
So you got the 0.3 because there's always a difference of 2 for the opposite?
No, you got 0.3 because whatever this smoothing constant is, the other one has to be the opposite of it, and they gotta add up to 1.
Okay.
So 1 minus 0.7 is 0.3. Now, here's where it starts to, you're using different numbers. Now, what was the actual for 2? It was 21? Okay, there's the actual for 2. Now we're on the forecast for period 3. 0.7 times the previous period actual, which is 21. The second period's actual is 21. Plus 0.3 times the previous period's forecast, which is 17. You see that what I'm doing, you go and you keep going until you get to the very last one, which will be period 12. And you get a forecast by using period 11's actual and forecast. Now what I've done is I've added some slides in the new PowerPoint because when I went over it, whoops, I didn't think it described it well enough. So here are the slides I added. Are you ready? All right. Here's the actuals: 110, 115, 125, 120, blah, 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 blah. The first forecast is going to equal what? We're using exponential smoothing with a smoothing constant of 0.1 on this one. What's the first forecast? Yes. Who said it? I heard it. Thank you, John. He barely shows up anymore. 110. 110. All right. The second forecast was the smoothing constant. 0.1. 0.1 times the previous actual 110. Plus, what's the opposite? 0.9 times the previous forecast, which is 110. What's your forecast for period 2? 110. You ready? Third forecast. 0.1 times the previous actual, which is now 115. 0.9 times that previous forecast, which is 110. 110.5. Period 4. 0.1 times the previous period 3's actual, which is 125. We went back and looked at the numbers. 125 is period 3's actual. The opposite, 0.9 times the previous forecast. The problem with exponential smoothing is that if you make a mistake up here in these first 2 periods, everything's wrong from that point on because you keep using the previous period's forecast. So one mistake makes everything off. That's the kind of difficult part about this. Let's try this again now. Everything's the same, but 0.8 is the smoothing constant. What's your first forecast? Let me go back to the data. What's your first forecast? 110 still. Your second forecast would be 0.8 times the previous actual 110, plus the opposite of 0.8, can be corrected. 0.2 times the previous forecast, which is 110. Your second forecast is 110, right? But your third forecast is 0.8 times what? Your third period forecast, 0.8 times, I can't, say it again. You said it. 1.
Is that a 6?
Yeah, 115. Then 0.2 times the previous forecast, which is 110. Right here. This is where we're at. 0.8 times the 115, 0.2 times the previous forecast. That gets us 114. We jump down to period 4. 0.8 times period 3's actual, which is 125. 0.2 times the previous forecast, which is 114. And it goes on and on. My question for you is, if this is on a quiz, it might say something like, use exponential forecasting to forecast the first 3-4 periods. Can you get that far? The first forecast, everybody's a gimme, right? Okay. You got that one. The second forecast, that's almost a gimme too, right? But show the work, even though you know it's going to be the same as the first forecast, because the actual forecast is the same on the first one. The third forecast is where the points are at. The fourth forecast is where the points are at. You don't have to do the rest. Everybody with me? Can you do exponential smoothing for at least 4 periods? Everybody, I see a lot of head shaking yes. Now, we're at the point to do our first error calculation. Trying to figure out which would be the best way to show you this. I'm going to go with this. we're gonna go with, I'm going with page, hang on. Where's the space period? That's a good one too, but, the 3-week moving average, there we go. I'm on page 670. Hey, come on. Okay, you ready? We're back to this data. Here's our periods, 12 periods. Here's the actual data. This is going to use the 3-period moving average. So to make sure I want to make sure we all understand where these forecasts came from. The first forecast is in period 4 because we're using a 3-period moving average. Tell me how to calculate that 19 for period 4. 3-period moving average. What am I doing?
Can you zoom in on that?
Zoom in?
Yeah.
Serious?
Yeah.
17, 21, 19, divided by
Wow, that's too much. Can't see the periods. Yes, Jasmine. You said 17 plus 21 plus 19 divided by 3. That's how that 19 for period 4 came about. Shift down. Now we're using period 2, 3, and 4 because they're the 3 periods before 5. To get that 21, it was 21 plus 19 plus 23 divided by 3. There's our period 5 forecast. And we kept going, shifting down, and we have, what do we have? 9 forecasts? Right? 9 forecasts. Now you can subtract this either way you want because you're going to get rid of the negative sign anyway. You can go straight across and subtract, or whichever way, but week 4, you really had 23. Our technique is saying it would have forecast 19. The difference, it's off by 4. Week 5, I can't see it. 18 minus 21, 3, or 21 minus 18, 3. Negative 3, positive 3, doesn't matter. Get them all subtracted. Now, get rid of the negatives. Right? All we're doing is get rid of the negatives, called absolute value. Add them up. 24. Divide by the number of forecasts you're using, which is how many? No. How many forecasts altogether? 9. You just calculated the MAE. Let me say it again. You find the error for every forecast that you can compare to an actual, which are 9 of them. Get rid of the negative signs. You should be able to do that in one step, by the way. Add them all together. Divide by the number of forecasts you're using. You just found the MAE, mean absolute error. 24 divided by 9 equals, calculator. All right.
2.666
Is it? 24 divided by 9, 2.67. That is your MAE. If we're going to use a different technique, we would find the error. It doesn't matter if let's say we're going to compare it to a 5 period. Everything's done the same, but your first forecast, we went from a 3 period to a 5 period. Your first forecast is not until period 6. So you have 6 through 12, which is only 7 forecasts. You find the error, you find the absolute value, but when you add them, you divide by 7. But now you've got apples compared to apples. And whichever one has the lowest MAP, that one's fitting that data better. Ready? You ready? Okay. So, right down here. Here is your MAE. All those absolute values added together, 24, divided by the number of forecasts we use, which is 9. There it is. And if we were doing a 5 period, we would get the total, but since we have to start at period 6, we would only have 7 forecasts. We divide by 7, and we're going to get a different number. And the quiz is going to say, here's your data, here's the forecast, calculate your MAE, or calculate your MSE. Which one fits the data better? That's where you're showing me that you know whichever one calculated with the lowest MAE or the lowest MSE is fitting the data better. Everybody hear that? Okay, hang on. We're not done because now let's do this again. Here's all, we're doing a 3-period moving average. Here's all my forecasts. I'm finding the error, but this time I'm squaring each error. The negative disappears. 4 squared, negative 3 squared, negative 4 squared, 1 squared, 0 squared. I add all my square errors. All right? And how many squared errors do I add? 9? 92 divided by 9 is now the big one. This is the important one. Each error squared added together divided by the number of forecasts, which is right at the bottom of this page. 92 divided by 9. The MSE, mean squared error, is 10.22. Now, I say, let's compare this to a 5-period moving average. We start doing forecasts. Period 6 is our first one. 7, 8, 9, 10, 11, 12. We compare it to the actual, we get our errors. We square each error. We add the squares. What do we divide by, Sierra? No. It's a 5-period moving average. No.
Okay,
7. There'd be 7 forecasts because we can't start till period 6. So 6 through 12 would be forecasts, but there's 7 of them. We'd square each error, we'd get a total, divide by. Now the formula looks like this, the sum of blah, 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 but it's just a matter of taking the errors, squaring them, adding them, divide by the number of errors you do. Now here's where you need to be careful. Are you ready? We're going back here. If you're calculating the mean squared error, in this example, this is exponential smoothing with a 0.1 smoothing constant, exponential smoothing with a 0.8 smoothing constant. Here's the weeks, here's the actual. When we did 0.1, here are the forecasts. But notice, the forecast isn't there for period 1. Because we didn't calculate the forecast for period 1 in exponential smoothing. We just said, whatever the actual is the forecast. No calculating was done. And it cannot be used for these calculations, MAE or MSE, in exponential smoothing. Exponential smoothing again. Never use the first forecast in your error calculation. Exponential smoothing. Never use the first forecast in your error calculations. And that's why it's left off here. It's left off there. You could not use it. There was no calculating being done in that first forecast. In exponential smoothing, the first actual was the forecast. There's no calculating. It cannot be part of this. Forecast. Don't use the first forecast for exponential smoothing when calculating your MSE or MAE.
So when do you start counting the forecast to find your MAE?
The second.
Well, the other one you didn't count with your first 4.
Because that was a 3-period moving average or a 5-period moving average. This is exponential smoothing. Now, 3-period moving average, your first forecast can't be till period 4, so you're only going to get 4 through 12, and that's when you divide by however many forecasts you get. If it's a 5-period moving average, your
So why
first...
can't it be till period 5?
Wait, hang on, I'm not sure I understand your question, so I'm going to go back to this. Hang on. This is a 3-week moving average, 3-period moving average. Notice the... Is this 3? Where's the first forecast? Oh, from down here, looks like it's 5. It's lined up with period 4. There's no way to get a forecast for period 3, 2, or 1, because you have to have 3 periods to do it. And then you can keep going. You shift down 5, 6, 7. So you can get this many. You want to get as many forecasts to compare to actual as you can. So, but you can't get one for the first 3 periods because there's no periods before that to get a 3-period. Okay, so if it's a 5-period, I want to make sure you got it. If it's a 5-period, your first forecast is in period 5-period moving average, your first forecast is in period 6. So you're going to do as many as you can. So there's 6, 7, 8, 9, 10, 11, 12, which are 7 of them. So when you get to the point of taking all these errors, you're only going to have 7 of them. And when you get to here to square them all, you're only going to have 7.
How do you know when to stop? How do you know when to stop at 12?
Because you don't have any more actual data to compare with. You could go on and do...
Because it's going to depend on the story.
Yeah, the story will only give you so many actuals, and you only do forecasts to compare to actual until it's time to forecast the future. But you have to find the best technique to use first. That's what I'm trying to get through here. When you're in a real job, any accounting majors, okay, you will be forecasting. You can't avoid it. It's impossible. You have to do budgets. Every company I used to consult with, every company I was the head of the business department, I was doing 5 years forecast for all of them. That's kind of a standard in the business world. Okay, you put it down.
No, I have a question.
Okay.
The question is, so is that weighted average or
No.
moving average?
You're dividing. It's moving average.
Moving average, and that one's weighted average.
You have percentages and you're adding.
And then the other one's smoothing something.
The smoothie is the one.
Smoothie.
Yeah. With the constant, with this smoothie constant. Oh, this is smoothie constant right here. Where's weighted average? We erased it.
I'm saying.
You don't have a weighted average up here. We erased it.
Yeah, but there's still some like 60, 20, 20 hanging
No.
around up there.
No.
Right at the very
Oh
top.
yeah, that. Yeah.
Just hanging around.
There you go. I don't want you to get confused.
All right.
Good. All right, but there's not a calculation. But you would be adding them.
Got it.
Okay.
I got the name.
Where were we? Where were we?
Okay.
My question, I guess, is, let me go back to, I want to go back to smoothing averages, because if you're being asked to calculate the MSE for exponential smoothing, you know, many people forget that you can't use the first forecast. There's 5 points right there. I don't want you to lose those points. You can't use the first forecast in exponential smoothing. And let me show you what's happening up here. All of this right here is when we're using the smoothing constant 0.1. Here's what we have here. 9 forecasts. 115 minus 110 squared. 125 minus 110.5 squared. 120 minus squared. Blah, 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 squared. Blah, 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 squared. We're adding the squares. And there's 10 periods, but we can't use period 1, so we divide by 9. Because there's 9 forecasts being used. There's our MSE. But we went ahead and said, let's use smoothing constant 0.8. That's what we did. Here's smoothing constant 0.8. Here's our actual way over here. 115 minus 110 squared. 125 minus 114 squared. Blah, 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 squared. Blah, 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 squared. Everybody get it? Add the squares. This is with 0.8. Different number. Divide by, there's still 9 again in this case. Which smoothing constant would fit this particular data better? 0.1 or 0.8? Gabriella. Today, let's. Darn. I don't know. I'm waiting to make sure. Damn. 0.8 why? Exactly. Everybody hear that? 0.8 because it's the lower MSE. What happened? It's not Gabriella? Gabrielle.
Yeah.
No, last time I said, you said this is a happy year.
Yeah, because I get tired of telling people what's on my name.
So this whole time you lied to me. And
I put Gabrielle on all my papers. You just choose to ignore it.
No. She uses 2 L's and an E, Gabriella.
No.
No.
It's an A.
That's
And
Gabrielle.
then I was handing it back. I said, Gabrielle. And she said, Gabriella. Like that. This was a half a year ago, like something like that. True or false?
False.
Are we good? Are we done? Are we done?
Yep.
Are we done?
Yes.
Let me look at the time. You guys, there's one more. Trend projection. Now, and the reason I really think we should keep going is because, in my experience, trend projection has been the very best, most accurate technique of any of these that I used in real life. Trend projection always gave me the lowest MSE in 90% of the cases. And I even, the president of Baker College at the time, and I was the business manager, and he said, I've been with Baker 30 years. I know what next year's revenue is going to be. And I said, well, I'll use whatever technique fits this data best, and we'll both come up with our forecast, and let's see. And we bet. And I want to tell you, trend projection is just all over it. As long as the economy keeps going the way it's been going with the past data you're using, you're going to be able to come up with some good forecast projections. And all of your budgets for the next 5 years start with projected revenues based on statistical forecasting, unless you're, an arrogant son of a bitch who was the president for 30 years and thinks they know better than any math formula in the world. And I know what next year's forecasting or effective revenue is going to be. We don't need to tell you that.
Yeah.
That'd be the only case you wouldn't use it. And even then, you're going to end up not being as close as you'd be if you get a technique. All right? Are we good? What did I say? All right. Are we ready? Here we go. Boom. All right. Now don't freak out. Whoops. Don't freak out. Hang on. Let me get it here. Right there. All right. Sum of ty minus the sum of t, sum of y divided by n. Don't worry about it. Sum of t squared minus sum of, long pause, sum of t squared divided by n. This is your slope. You're going to then use that slope to find your intercept. Once you have your intercept and slope, you can forecast any period in the future. You don't want to go too many years out or too many periods. You want to reevaluate it after a year and recalculate what. That's all there is to it. Now, how do you get these sum ups?
I can't read any of that.
You can't read any of this?
No. The camera's too tilted. You zoom it out.
Oh, tilted too? Really? I
Yeah,
can read
it's
it now.
looking like from the top of the book. It's not straight down on the page. No, like,
Move the
no.
arm. Move the thing
Rotate.
forward.
Look it out there. We ready?
Is that
Okay. You want to form columns. This is the best way to do this. You form your 4 columns, and you follow that process, and you're going to come up with each one of these numbers, and then you just plug them into this formula. You ready? Here's your data. All right. Can you see this? You can. I got to do this. Can you see that? I'm going to zoom in on this. Can you see this data now? Can you guys see this? Anybody?
Yes.
All right. You ready? Here are the time periods. Here's the actual data. Stop there. This is given to you. The first column is your time period. 1 through however many time periods you have. Add the time periods up. 1 plus 2 plus 3 plus 4 and so on. Right there. That is, you just found, I don't have any room here. We need more boards. I would pay somebody to just hang out and linger here and erase as I'm talking so I can come back and just keep writing.
I'll do it.
I didn't mean in the class. You gotta be here to, for the thing. I mean, I would pay somebody like, I don't know. The sum of t equals 55. By just adding the time numbers, you're finding the sum of t. Here's our actual data. You're given this. It is lined up with the time periods, just like this. You add those up, and you just found the sum, as we look at y, but that's the sum of y, 264.5. How are we doing? We're doing okay. We're gonna get there. Everybody with me so far? Now, those have been given to you. You just have to add them up. You got your first 2 of 4 out of 6 pieces of data, really. Here they are. What happened? Sherry?
I have no idea, it just went right over me.
What they're saying or what I'm saying? I don't know which one or both. I don't know what.
All of it.
Oh, thanks. Here's the next column. Ty, t times y, goes straight across with each period. 1 times 21.6, 2 times 22.9, 3 times, 4 times, 5 times. This allows more weight to be put on the more recent data compared to the old data. Down at the bottom here, 10 times 31.4. Much more weight there. Bigger number. Once you do those straight across, you add those up. And now you just found the sum of Ty. That's an ugly one. 1545 point what? 5. Thank you. All right? We have the sum of t, sum of y, sum of ty. Your last column. Take each time interval, square it. 1 squared, 2 squared, 3 squared, 4 squared, 10 squared. And you just, and add them up. You just found your sum of t squared, which is 385. These 4 numbers are 4 of the 6 numbers in all that other calculation. All the work is just finding these numbers so you can plug them into the formula for the slope. There's 2 more numbers. The mean of y and the mean of t. That means mean. 55 divided by 10, mean of t, 5.5. 264.5 divided by 10, 26.45. Thank you. There's our mean of y. There's our mean of t. Here are our 4 sums. Now we go back to this. Whoops. Right here. Here it is. I'm going to plug them in here now. You ready? Go ahead. Hit me, Sherry. Go ahead.
I don't know where that Y came from.
Which Y is that one? This one right here?
Yes.
How do you?
Or this one?
That one.
I took this right here, the sum of y, which is right here, and divided by the number of periods.
Okay.
So that divided by 10, I just moved the decimal over because I was dividing by 10, so I just took the easy route. That was you.
Oh, I never leave class.
Okay. Well, you hardly show up, so it's how would you be able to do it? All right? All right? It's the last lecture. Am I taking advantage of things here? You know what's happening? By the way, I need one more evaluation. I'm sure I'm going to use a good one.
It was a superb evaluation.
Oh.
He's gonna go change it now.
Yeah, I know, exactly. Thank you. That's what I meant. But I need one more of someone who didn't do it, and we reach our goal of 90%. So we all get extra credit.
Right?
The same extra credit you've gotten all semester. I always say that. When someone says, "Are you giving me something for Christmas?" I said the same thing I got last year.
Wait, so you need 19 evaluations?
No, yeah, 19 on 31. No, 27.
28.
28. There's 27 now. Is it 27?
I was number
27.
27.
I just need number 28 out of 31. Gabrielle, not you, please. Oh, okay. But I did. Thank you, Sarah. Thank you. I said the right name. Is that what you said?
No, you said the wrong one.
No, I didn't.
You said Gabriella.
No, I didn't. Help me. Thank you.
For once.
I heard Gabriella.
That's what I heard too. I think we were just used to it.
Yeah, I know. And people hear what they want in big class. You ready? Oh, sure. Are we ready?
I'm ready.
Okay, let's go.
Waiting on you.
All right, so let's do the slope. Sherry came into my office one day and said, "How do I get my son to put the seat down?"
I did.
And I said, "Just tell him to start sitting down."
Because it's healthier for you.
That's right. That's the answer. Once you start getting older, you learn just sit down. Yeah, it is. Just sit down. You guys don't. Oh, it's not manly. Just sit down. You ready? Are you ready? I gotta cut that out of the video, by the way. I'm up at the numerator right here. I'm right here. Sum of ty. Look at all the numbers we got. Sum of ty. What do I have? 1545 minus says the sum of t. What did I do wrong? What do I have?
Yeah.
Oh, 0.5. Sorry. Okay, hang on. 0.5 minus. We don't have time for this. Okay. What's the sum of t? Right up. Okay, not all at once.
55.
And then what's the sum of y? 264.5? How many pieces of data do we have when we had the whole list? 10 divided by 10. Over. Now be careful. We're about to get to where, if this has to be done, I'd say almost 40% will make a mistake right here. Here's the deal. The denominator is the sum of t squared, which is, I can't see that one, 38? Oh no, what is that? 385? 385 minus, now be careful, this is not the sum of t squared. This is the sum of t squared. Just give me the sum of t. 55 squared divided by 10. That's your slope. You just do the math. Boom. Done. What does it equal? Let's go to the next page. Now, once we get there, let's do the intercept. The intercept is the mean of y. Sure, you were asking about it. 26.45. It's 26.45. 26.45. Is it minus or plus? This is, be careful. This is minus. If this is a negative slope, it's minus a minus, okay? But it'll be a positive slope, I think. Whatever the slope is right here, times, we'll have it in a minute, times the mean of t, which is 5.5. Right there? That look good? There's our intercept. There's our slope. Let's calculate the slope by turning the page. Make it easy. All right. The slope is 1.1. So I'm putting 1.1 here, and then this equals
20.4.
20.40. You have the slope. You have the intercept. You now can forecast any period you want. I want to forecast period 14 because it went to 10, right? So I'm talking about 4 weeks later, or 4 months, or whatever the periods were. So how you would do it, the forecast, if I turn back a page, where is it right there? Oh, it's right there. It is the intercept 20.4. Now this one's always a plus. Plus. The slope, 1.1 times whatever period you're forecasting. I want to put an arrow there so you can see. The reason we use 14 is because we're trying to forecast period 14. And then every forecast is exactly like this. You're only changing this number, the period in which you're forecasting. You can use 11, then do a 12, then do 13, then do 14, 15, 16, whatever. That's all you change. All this work is so you can do forecast after forecast after forecast based on period numbers. Now I want to make sure you're ready for period numbers. Let's say this data went to December. Period 10 was December. The question says, use trend projection to forecast March. What are you going to do? You got your intercept, you got your slope, but what goes right there? Say it again.
13.
If December's 10, March must be 11, 12, 13. You put a 13 in, and then you get your forecast. It's that easy. It's that easy.